Good morning, everyone. I'm here to present RUVA, a system for personalized, transparent, on-device graph reasoning. Let's look at the current state of personal AI. We are facing a landscape defined by fragmentation. Your digital life is siloed. Your calendar doesn't talk to your gallery. Your emails don't talk to your notes. Current personal assistants have point-specific knowledge, but lack the interoperability to perform true cross-domain reasoning. If you ask a standard assistant a question that requires connecting these dots, it usually fails. Or worse, to make it work, you have to upload your entire digital life to the cloud, sacrificing data sovereignty and privacy. The industry's answer to this has been the retrieval augmented generation, or RAG. But standard vector RAG creates a black box problem. Vector databases rely on statistical similarity. They struggle to capture deep, implicit structural relationships like time and causality that are obvious to a human but invisible to a vector embedding. Most critically, you cannot truly delete a concept from a vector space. You can only suppress it. This leaves behind what we call a probabilistic ghost, mathematical traces of a sensitive data that an AI might accidentally resurrect. This violates the fundamental right to be forgotten. We propose a paradigm shift from black box retrieval to a glass box architecture. We call it RUVA. RUVA is a neurosymbolic graph RAG architecture that runs entirely on device. We built this to be an oracle for your personal data, transparent, private, and verifiable. How does it work? Instead of just vectors, we ground the AI in a personal knowledge graph. We implement the graph over a standard SQLite database. This means every memory is a discrete editable node, not just a floating number in space. We use an on-device small visual language model, specifically Gemma 3 Nano, acting as the eyes and ears to convert unstructured data, images and text specifically, into structured triples. We apply community detection algorithms like Leiden to resolve entities, ensuring that Sarah in your contacts and Sarah in your email are recognized as the same node. Adopting this architecture also ensures the much discussed right to be forgotten. Deleting something from the graph makes RUVA not consider it for further reasoning. RUVA's functionalities through three real-world scenarios. First, we show the multimodal ingestion through Gemma 3. Then, we show RUVA's advanced reasoning capabilities. And finally, we show the deterministic deletion mechanism. Let's start with scenario 1. We want to prove that adding a node into the system, we are able to access its content during RUVA's reasoning phase. Here, we're adding a node about my friend Mark's allergies. Mark is allergic to all kinds of fish. Behind the scenes, the local SLM extracts the metadata and injects them as nodes into the personal knowledge graph. Now we ask, do you know Mark's allergies? The system queries the graph and answers correctly. Yes, Mark is allergic to all kinds of fish. This is according to the note titled Mark's allergies. This confirms the information object has been successfully ingested and grounded. Now let's push the system harder. We are now adding an alarm as a reminder for a fish dinner with friends. It will take place today at 7 p.m. The system now has two separate pieces of information, the note from scenario 1 and the alarm we just set. We ask a natural language question that requires reasoning. Can I invite my friend Mark to the fish dinner with my friends today? Watch what happens. The system answers. Yes, you can invite your friend Mark to the fish dinner with your friends today. Mark is allergic to fish, so you should be mindful of that when preparing the meal. It successfully bridged the gap between a note and an alarm using the graph topology. Finally, we address the most critical aspect of privacy, the deletion. In a standard LLM, you can't surgically remove a memory. In RUVA, you can. We select the node we previously added and hit delete. This procedure triggers a standard SQL delete cascade transaction. The node, its properties, and these associated vector indices are instantly excised from the database and from the graph. We ask the same question as scenario 1. Do you know Mark's allergies? In conclusion, we showed that RUVA can transform heterogeneous data into a structured personal knowledge graph. This graph enables complex reasoning via a local vision language model and is able to uncover implicit relationships that standard RAG often miss. The system operates fully on device, ensuring that user data never leaves the hardware and guaranteeing deterministic deletion when permanently erasing data from the PKG. Thank you for your attention.